Today we're going to talk about decision analysis, a brief overview. We see decision analysis as a philosophy, a framework, a process, and a methodology. Next time we'll talk about uncertainty. Probability is the language of uncertainty. We'll also discuss probability assessment / encoding methods and discrete approximations. Our course learning objectives for decision modeling and analysis. By the end of the course, we hope that you will be able to identify and frame key issues of decisions, create doable alternatives, obtain decision-relevant information in an unbiased manner, define values and trade-offs, analyze, evaluate, and compare each alternative, and then finally present a cogent case to gain commitment to action. This course will improve your decision-making, modeling, analytical, and Excel skills. There are many complexities or factors that affect decision-making. There's the uncertainty in changing information, the interdependence of projects or the actual project itself. There's always different views of what's important. A lot of conflict resolution that may need to happen. Decisions are often subject to critical review, and of course there are investments required for each decision, and invariably we never have enough resources to commit ourselves to the investment. And then because we have multiple views, we also have multiple objectives and strategic considerations that we may need to take into account. And then with a decision, as you make a decision, you go down one path and the other path is no longer an option. So it's kind of a future looking. And then finally, big data. Data is everywhere but nowhere. And what I've found in industry is there's a lot of data out there, but it's not always relevant to the decision that you're helping or that you're making. Decision analysis provides a necessary framework to make quality decisions logically consistent with what the decision maker can do, the alternatives, what the decision maker knows or doesn't know, which is your uncertainties, and what the decision maker wants or values. And we do this by identifying framing key issues of the decision. Those issues include the alternatives, the uncertainties, and the values. We create doable alternatives. We obtain decision relevant information from subject matter experts in an unbiased manner. We define values and trade-offs for the decision. We analyze and evaluate and compare each alternative. And then we finally gain commitment from the decision maker. To deal with these complexities and real-world problems, decision analysis uses a structured process which I call the decision analysis cycle. And the way it works is it's a step-by-step process, and there's 4 steps to it. There's the basis development, deterministic structuring, probabilistic evaluation, and then the basis appraisal. And there will be times that you have to iterate back through to the different stages, different steps. And then hopefully finally you'll come to some kind of action. So under decision basis, the basis is what we've already discussed. It's your alternatives, the uncertainties and values, and some of the key tools that we use are the influence diagram, this is a simple example of an influence diagram, and also the decision tree. During deterministic structuring step, we're building a model, financial model, more times than not. We're assessing ranges of uncertainties, and we're determining sensitive uncertainties using a tornado diagram. And there's an example of a tornado diagram. In the probabilistic evaluation step, we are encoding or assessing probabilities from subject matter experts. We're evaluating the alternatives and some of the probability encoding methods that we'll talk about later in the course, some of the methods and tools that we have available. And then the basis appraisal is where we evaluate or determine value of more information if it's worthwhile to gain more information. And then we assess decision quality and make recommendations or iterate, refine the analysis. The purpose of this exercise is to illustrate the basic principles of decision analysis with a simple investment decision. Warning: business decisions based purely on instinct may be risky. The next time you have a gut feeling about something, make sure it isn't just indigestion. The gut instinct with decision analysis, the key there is breaking it down to smaller components, smaller factors, so you can use your gut at a level that's appropriate. If you try to make an overall arching decision, a lot of times using your gut, you may be missing some of the factors that would influence your decision. So here's the investment opportunity. The decision is whether to invest $5 in a venture. The uncertainty is, will the venture succeed? And then there's the alternative is, if it doesn't succeed, then there's failed. These are the two different, the uncertainty is if it succeeds or not. And the outcomes associated with that is you could receive $20 or receive nothing. A good decision is logically consistent with what you can do, what you know, and what you want. That's our decision basis. And decisions have options or alternatives. In this example, we use a yellow rectangle to represent our decision, and the decision is to invest or not. And the underlying options or alternatives are yes, we invest, or no, we don't invest. The uncertainties, we use a green oval as convention to represent the uncertainties, and there are outcomes with the uncertainties. In this case, the outcome is either success or failure of this investment decision. And then finally, the values are consequences associated with the outcomes, and we have a payoff. What we can do is we can either gain $20, win $20, or lose or break or do nothing, gain nothing. A decision tree helps us organize and display the chronology of events. So reading this from left to right, you have a decision of invest, and there's two alternatives. There's the yes branch and then the no branch. From the yes branch, you have an uncertainty. You can either succeed or fail, and then the blue triangles represent the different outcomes associated with that. So, for example, the top path through the tree is a yes investment and then success, and then there would be a corresponding value proposition from that. Probabilities help quantify the likelihood of success, and usually we attain these from subject matter experts. So we're looking at filling in the probability P of success, and then 1 minus P would be a probability of failure. For each of the uncertainties, the probabilities of the branches have to sum up to 1. So filling in some of our numbers, we have the investment decision, either yes or no. We have the probability of 0.5 of success, and then finally we have gaining or winning $20, but we've spent 5, so we would have a return of, or a payoff of 15. Similarly, in the yes branch, but now we fail, we have a -5 because we gain nothing and then we lose the $5 we invest. And then finally, we have the do nothing alternative, which we call not investing or no invest, and that has a return of 0. The rollback evaluation is the way we evaluate our decision trees. It starts at the right-hand endpoint of the tree, which are the blue triangles, and computes the probability weighted average or expected value for the chance node, for different chance nodes. So as we start on the far right, we come to a uncertainty. So that means we're going to do the probability weighted average or the expected value. So the expected value, or EV, is equal to 0.5 times 15 plus the bottom part of the tree times -5, and if you go through that math, you'll get 5 as the result of the expected value. So this whole uncertainty node, the expected value of that is $5. And we can collapse our tree to represent the 5 by just eliminating the uncertain node, and we're just left with 5. The rollback evaluation determined with this expected value determined, now we're reduced the tree, and now we come to a point where we have a decision to make. So this is a choice, and we choose the yes branch because it has a higher value than the no branch, no alternative. If it was cost, it would just be the opposite. So in this case, the expected value is the maximum of 5, 0, 2 values associated with that, and 5 would be our max value, and consequently we have an arrow pointing to yes, meaning this is the path we want to select, and then the stop sign, or this path, these double lines representing the stop. A good quality decision is logically consistent with what you can do and what you know and what you want. Have we developed the appropriate frame for the decision we just looked at? I think so. Have we created doable alternatives? Yes. There's only one alternative. There's 2 alternatives, 1 decision. Meaningful, reliable information. In this case, we've assessed the probability to be 0.5. The values are the payoff of 20 or nothing. Have we applied logically correct reasoning? I would argue that decision tree analysis provides that. And then are we committed to act? And this is just what we call a decision quality diagram, which allows us to, as more complicated problems, using this to determine where we're at in our quality. So ideally, you'd like to have everything at the far or the outer rim. That means you're at 100%. You've gone as far as you can with that. But as the project starts, you'll have something here, and a lot of the other ones will be pretty low. You've defined what the scope of the problem is, and then that may be at 80 or 90% or even 100%, and then you haven't done any creative doable alternatives, or maybe you've done a little bit. So you can see that you could have a line from here to here, and then so on and so forth. But at the end of the day, when you've made commitment to action, you would hope that you would be peaked out at 100% or at the outer rim for all the different factors that you're looking at to make a good quality decision. And life is full of choices and outcomes or consequences. The decisions you make will shape your life. As you can see here, we've come to a fork in the road, and we've decided to go down this path of your life versus no longer an option. And what we're doing is just pointing out that this is future looking. So decision analysis functions at 4 levels: as a philosophy, as a framework, as a process, and as a methodology. We've covered some of these, but later in the course we'll talk more about this. But as a philosophy, decision analysis provides a rational, consistent way to make decisions. It takes into account the uncertainty of future outcomes of our decisions. It also provides a distinction between good decision and good outcome. Good decision is the best we can do, and the good outcomes, the good decision essentially is what process that we use and what logical framework that we use to make that good decision. And then the good outcome is what results from making that. It doesn't necessarily have to be a good outcome. It could be a bad outcome as well. Decision analysis does operate as a framework for decision making, and it provides concepts and language to help the decision maker. And we've already talked about the decision basis, the alternatives, uncertainties, and values that are contained in each decision. We've talked about decision quality. As a process, decision analysis provides a step-by-step procedure that has proved practical in tackling even the most complex problems in an efficient, orderly way. And this is the decision analysis cycle, which we briefly talked about, but we'll talk more about that later in the course. And as a methodology, decision analysis provides a number of specific tools that are sometimes just indispensable in analyzing the decision problems. And they include the decision tree, which we talked about today, the expected value, and then the rollback evaluation method, which we use to evaluate the investment alternative.